One of the key decisions that you have to make when architecting a system using microservices is figuring out how to partition your application into a set of microservices. So in this segment, I'm going to describe various different partitioning strategies that you can use. It's important to remember that one of the goals of partitioning is to enable parallel or concurrent development. So the development of different services can proceed concurrently with the development of other services as much as possible. Because if you can accomplish this, this will significantly increase the velocity of your team. So there are a few different partitioning strategies that you can use. So one approach is to partition by noun. So you define a service that's responsible for all of the operations on a particular type of business object. So you could say that the catalog service, which maintains product information, is an example of that, right? Anything to do with product information resides in the catalog service. And it would have a REST API for adding and updating products, searching them, retrieving them, etc. Another way of partitioning your system is to partition by verb. So there you would have a service that's responsible for a particular use case. So for example, you could have a web application that implements the checkout UI. So it's just implementing those web pages that are part of the checkout process. You could, for example, have a shipping service that's responsible for all aspects of shipping. So those are verb-oriented services. Another way of thinking about it is to take some concepts out of domain-driven design. So if you think about everything your organization does, that would be a domain. But then within that domain, there are various subdomains, different functional areas within your business. So you could have a service that implements the business logic for a particular domain. So yet another guideline. Then we could also think about some ideas from object-oriented design. Quite a few years ago, Bob Martin, who is an expert on object-oriented design, came up with a set of guidelines or principles. And one of them was the single responsibility principle. And what he said was that a class should only have one reason for change. In other words, it should only have a single responsibility. So we could apply that concept to service design and say that a service should have a single responsibility. So that would lead us to services that are quite small and cohesive. Though to be honest, the actual definition of responsibility is somewhat loose. So different people might have different interpretations of what that means. You could also take inspiration from Unix. So if you think about the Unix command line, instead of there just being the monolithic command line process, instead what you have in Unix is a set of utilities, cat, grep, find, etc. Each one of those things performs a fairly focused task. We could adopt that metaphor for designing our service, have services that just do one focused thing well. And then we can tie them together with communication mechanisms to accomplish larger tasks. But one of the interesting challenges with partitioning the services is, as well as partitioning our actual business logic, we're also partitioning the database. And this introduces a really interesting challenge: how to enforce data consistency, or in other words, how to enforce invariance across multiple services without using two-phase commit. And I'm going to revisit this a little later when I talk about event-driven microservices. But here's one of the examples that I like to use. So imagine you have orders, right? Orders have a total. And then imagine that you have customers, but there's one sort of wrinkle where a customer has a credit limit. And the idea here is that the outstanding orders for a given customer must not exceed the credit limit. So that's an example of an invariant, a business rule that exists within the application that must be enforced at all times. So if that's a monolithic application, you can just easily accomplish it using an ACID transactions. In a sense, you can think of that's one of the goals of ACID transactions, is to ensure consistency, or in other words, enforce these invariants. But then, if we decompose the system into services where we've got order management service that holds the orders and customer management service that holds the customers, how do we enforce an invariant that is spanning those two services? So you're going to see that can be a major challenge, because on the one hand, we want to be able to partition up our system, but we also need to enforce consistency. And in later segments, I'm going to talk about an event-driven architecture that can enforce invariants across multiple services, albeit in an eventually consistent way. Another challenge with partitioning is that it actually requires you to have a good understanding of the design of your system. You actually have to know what it is that you're splitting up. So if you have an existing monolith, that's fairly straightforward to figure out how to partition it. You have an existing set of modules with dependencies between them, so you kind of know what it is that you want to break apart. There might actually be a challenge with untangling it and properly modularizing it in order to do that, but that's kind of a separate problem. What's a little more challenging is if you're doing greenfield development. On the one hand, you have no code, which means that you don't have any tangled dependencies, but you don't actually have a good sense of what the structure of the system actually will be. And so there, I think it makes sense to do a bunch of upfront design or prototyping, build an evolutionary architectural prototype of your system so that you understand the shape of it, and then hence the ways in which you can partition it. Another thing to think about is, well, how many services should you use? On the one hand, if you've got a large system and you haven't partitioned it enough, then the problem you have is that instead of a monolith, or a really, really big monolith, you have a few moderately sized monoliths, and you haven't actually solved your problem. In theory, you could actually have too many. In the SOA world, they call that the nano-service anti-pattern. But in the microservices context, it's a little more nuanced than that. On the one hand, every service has a runtime overhead. And so the more services you have, the more overhead there is. So for instance, each service could have its own JVM. That actually means that you've got the overhead of a JVM for each service. And say if your service is only 100 lines of code, that's an awful lot of overhead. So that's one challenge. Another interesting issue around the number of services is really the style, the communication patterns between them. Some ways of partitioning the system up could result in large numbers of network hops. So imagine if A depends upon B, which depends upon C, which depends upon D, so on and so forth. And in order for A to return a request, it actually had to go all the way to service Z. That's a lot of latency in your system, which could be sort of too expensive. On the other hand, if service A can call services B, C, D, and E, and so on in parallel, then that's, because it's all happening in parallel, the cumulative latency is not that high, and it's not, and latency would be quite acceptable. So not only is it kind of how many services you have, but you have to think about the communication patterns that they're using. If it's sequential, that could be bad, but if it's in parallel, that can be acceptable. One other problem, though, you have to think about is, in a way, when we're decomposing the system into microservices, we might actually be moving the complexity into the space between the microservices. So we're actually, the services themselves are quite simple, but the actual patterns of communication that could actually be quite complex. And so you can think of the complexity as being in the space between the systems. Though in some ways, that might not actually be any worse than a monolith, which actually has modules which are communicating anyway. And so there's sort of bits that have to communicate. So it's, you know, so there are some issues, but it's very nuanced, and it very much depends on the particular application that you're building. However, one thing that you want to avoid is the distributed monolith anti-pattern, because that's where you sort of get the worst of both worlds. So the idea here is that you break up your system into services, but you do it in a way such that every change requires you to update every service. So you actually have none of the benefits of microservices because you don't have independent deployment. And plus, you have all of the complexity of microservices as well. So it's sort of like the worst of both worlds in a way. So one of the other things you need to think about is another Bob Martin principle from OO, which is the common closure principle. And at the time, he was describing, it's about modularity, and he was describing what components should be packaged together in a module. And what the common closure principle says is that components that change for the same reason should actually be packaged together. So you can think of putting components that change for some similar reason into the same microservice. Because if they were in different microservices and they changed in lockstep, you would have to redeploy, update, and redeploy multiple microservices. So a few guidelines there. So to be fair, partitioning is something of an art. It actually depends very much on the specifics of your application. And so what I've outlined here is just some guidelines that can get you started. And here's an example. So this is an article I wrote a few months ago, and it's about an Uber-like system. So it's for matching passengers that need rides with drivers who can pick them up and transport them. And here's a here's a monolithic architecture. And there's different functions packaged together within the same monolith. And here is an example of a microservice architecture for the same system. So there's services that manage passengers, there's services that manage drivers, there's a billing service that bills the passenger when a trip completes, and there's a payment service that pays the driver when a trip completes, and so on. So you can see that we've broken up this ride application into a set of services, each one that's responsible for a particular function. That's partitioning in a nutshell. And as I mentioned, it's very much an art, and it's very dependent on your particular application. But in practice, once you get into the idea of breaking things apart, it's usually straightforward to come up with a partitioning that works well for your application.